In this question, we have triangles DOG, right? So that's this triangle here, DOG, it's the larger triangle, with altitudes OC and GE. So the altitudes, I'll label those. OC, right here, and GE, right there. Altitudes, remember, form right angles, right? They're the perpendicular distance from a side of a triangle here, or perpendicular line from the side of a triangle, and and they intersect at point F. Okay, so that's this point right here. I always label things as I go because seeing the letters alone and the diagrams separately can be overwhelming. So I always label as I go to make sense of the problem. Here in part A, they say if OD equals OG, so that means that, and I would label this OD, right, and OG, these two lines are exactly the same. So this DOG is an isosceles triangle. Name two triangles that are similar. Well, I guess the hint here for me, we could look at this in terms of isosceles triangle and work with the benefits of an isosceles triangle here. I want to go more for the fact that we have these right angles. So that means that for similarity, right, we're looking for similarity here, with right triangles, all we need is a hypotenuse and a leg, right? If you think about similarity for right triangles, that's all we need. If we have two right triangles and the hypotenuses are equal, and we find one pair of legs that are equal, then we know those two triangles are similar, right? And that has to do with the fact that all right triangles already have right angles. So we know they already all have one corresponding angle, an equal angle. So we can use that and then only establish that if hypotenuses are equal and a leg is equal, then they're definitely similar. Okay, so can we do that for any of these triangles? Yeah, well, if OD and OG are equal, right, we can think of those as each as being a hypotenuse. OG over here, right, let me label this. If we have OG, right, that's a hypotenuse, right, for this triangle here. For triangle COG, COG, right, this altitude OC that comes down forms a right angle here, and that means that this leg is the hypotenuse. And the same thing on the left-hand side, this is a hypotenuse too, right? DO is a hypotenuse for triangle DOC, right? Here's the right angle there. So we have two hypotenuses and we're told they're equal. So we already have a hypotenuse. What's nice is they also share this leg right here. They both share leg OC. So that leg, of course, is equal to itself. These two hypotenuses are both equal. They're right triangles. So that means triangle DOC is similar, right, to, just different symbol there, similar to triangle COG. And okay, we've got that. Now here they want a different pair of similar triangles. Well, there are lots of triangles forming here, right? And we can go different ways in looking at this. But the other pair of similar triangles I would use is right here, right? We use these two vertical angles. These angles are equal, right? Vertical angles are equal. Okay, so we have those two angles, they're equal. And then I noticed that this is a 90-degree angle, FCG, and OEF are both right angles. So that means that we have, I'm going to color these in actually, this triangle right here, and this triangle right here, right? So that's triangles FCG, right? Triangle FCG we're looking at, and triangle FOE, FOE. And I should actually reorder that, because if I said FCG, point C at the right angle, here I would say FEO, right? You want to list those points in the same order. And those two triangles are also similar. And the reason for that is that all of their angles are equal, right? These vertical angles here are equal to each other. The right angles are equal to each other. And if you've got 2 out of 3 angles equal in a triangle, the third angle must also be equal, right? For example, if these two angles are both 90 degrees, right? If this was, different color, if this was 90 degrees here, and this is 90 degrees, and let's say this is, I don't know, 30 degrees up here, So, oops, so sorry. If the vertical angle was both, let's say, 30 degrees, that means what? Well, if the vertical angle is 30 and the right angle is 90, that's 120 degrees. So there's 60 degrees left over in both triangles. This angle here would have to be 60, and so would this one, right? So that remaining angle must be equal. So if you have three angles that are equal in both two triangles, you know they're similar. All right, hope this helped.